So recently we've been investigating Le Chatelier's principle and the effect that concentration and temperature might have on the equilibrium system. Today what we're going to look at is the effect that pressure will have on that equilibrium system. Let's go. Okay, so we've already done a bit of this investigation in class where we're looking at the effect that changing the pressure on a system has on equilibrium. So let's have a look at the example that we have here on the board where we have 2 moles of SO2 and 1 mole of oxygen, and in the forward reaction it's producing 2 moles of SO3. All of these are of course in the gaseous form. So when we increase the pressure on the system, we're actually decreasing the volume. So the reactant particles are in a smaller space, so we're having those increased collisions. And due to those increased collisions, that's driving the reaction to the side where there are a smaller pressure in terms of 2 moles of the SO3 gas. So the reaction will shift to the right-hand side. So the reverse of that, of course, is when I decrease the pressure or increase the volume. And when I'm increasing the volume, the reaction's wanting to move to counteract that, and so we've decreased the pressure, so the reaction's wanting to counteract that by increasing the pressure, and it's going to do that by moving to the side where there's the greater number of moles, therefore the greater number of particles again. So looking at that with Le Chatelier's principle, it's saying again that the system will respond to that increase in pressure by adjusting to decrease the pressure, and therefore the equilibrium will move to the direction of the fewest gas particles. And of course the reverse can be true. If I'm decreasing the pressure in a system, the reaction is going to try and counteract that by moving to the side which will increase the pressure in the system, which will be moving then to the side with the greater moles of gas. Thanks for watching. We'll discuss this a little bit more in class.